Hello, we are continuing solving the gateway problems for Math 104. This is question 24, and the question is asking us to solve for z in this equation. So we're going to utilize this list of steps here that we saw was very helpful in the last problem, and we're going to do that as well again here. So the first thing we should do is look for common factors. So of the three terms here, 15z to the 3/2, 29z to the 5/2, and negative 14z to the 7/2, we want to factor out as many things as we can. So each term has a power of z. So what we would like to do is factor out as many powers as we can, which in this case is the lowest number. So we're going to factor z to the 3/2. Now let's take a look at the coefficients, the numbers we see here, 15, 29, and negative 14. Unfortunately, these numbers don't have a common factor, so we can't factor out a coefficient. But we can factor out z to the 3/2. So what's left when we do that? Well, the coefficients are going to stay the same. And the powers of z are going to decrease by 3/2. So this term, z to the 3/2, becomes z to the 0, which is just 1. Z to the 5/2, subtracting 3/2 from 5/2 gives 1. And subtracting 3/2 from 7/2 gives 4/2, or 2. So z squared. So now we're going to use the zero product property, which says if two terms multiply to 0, then one of them must be 0. So either we have this term equals 0, or this term equals 0. So one of these is a quadratic equation. We'll deal with that next. But first, let's consider z to the 3/2 equals 0. So if z, we'll do this over here, if z to the 3/2 equals 0, what must z be? Well, the answer is 0 for much the same reason. So z equals 0 is a solution of this equation. Next, we want to look for roots of this quadratic equation. So we're going to consider that now in its own right. 15 plus 29z minus 14z squared equals 0. Now, this step is not necessary, but I think it helps sometimes. I like it when the leading coefficient, which is the number in front of the highest power, is positive. So what I'm going to do is multiply this whole equation by negative 1 to make it so. And I'm going to multiply by negative 1 on the right as well. Of course, the right-hand side is 0, so it won't change the value, but it's good to do. So what's left? Well, my leading coefficient becomes positive, which is what we wanted, and then these two become negative. So, since this is a quadratic equation, we should use the quadratic formula to solve it. So, what I'm going to do now is identify each of these coefficients with a, b, or c in the quadratic formula. So a is this number, 14. B is this number, negative 29. And c is this number, negative 15. So the quadratic formula says that z is equal to, sometimes I like to sing the song or the quadratic formula to the tune of Pop Goes the Weasel. I warn you, you'll never get it out of your head if you do it this way, but you'll never forget it either. So z is negative b plus or minus the square root of b squared minus 4ac all over 2a. So using these numbers, negative b is 29 plus or minus the square root of negative 29 squared. Be sure you put the negative sign in these parentheses so you don't make a sign error. Then minus 4ac. So 4 times 14 times negative 15. All of this is under the square root. And then our denominator is 2a. So 2a is 28. Well, at this point we have to do a little arithmetic to clean this up a bit. The negative in this term will go away when we square it, and 29 times 29 is 841. Then the product of these numbers, 14 times 15 is 210, times 4 is 840. So the term in the square root becomes 841. Erase this to make it a little clearer. 841 minus 840. But these negatives make a plus. So that's our square root. Okay. At this point, I'm going to erase some of our earlier work just so we have a little bit more room for this arithmetic. At this point, we will get two solutions from the quadratic equation. One of them will be adding this square root term, and one of them will be subtracting the square root term. So in addition to our z equals 0 solution we had earlier, we're also going to get z is 29 plus this term, and we don't need to do any more arithmetic at this point, as well as z equals 29 minus the square root term. Both of these are valid solutions. So all that remains is to check the answers. That is to plug these numbers into the equation and see if they do indeed produce 0. At this point, we have three solutions for this equation. We have the z equals 0 solution that we got by factoring the z to the 3/2 out, and then we have these two solutions produced by the quadratic formula. Now, since these solutions were obtained only by factoring and not by substitution, they are indeed correct solutions. So we do not need to check these answers in the original equation. We could, and if we plugged these values in for z into this original equation, a somewhat laborious computation would prove that they do indeed produce 0. But since we found these answers solely through factoring, we do not need to substitute.